what we're going to do today is wrap up some discussions of terminal operations, focusing on another variant of collect and collector. And then we'll continue marching through the parallel stream stuff that we've been looking at. What we're going to talk about here is how to use something called the JavaTeeing Collector, which is a really interesting collector that was added in Java 12. So the JavaTeeing Collector is a collector that returns a collector that's a composite of two so-called downstream collectors. So what the heck does that mean? That means that you've got a stream with some values in it, and you give it two collectors, and every element in the stream is passed to both collectors, and they do stuff to the elements, whatever they're going to be doing. There's filtering and mapping and so on that you can do. And then after the two collectors get their turn at modifying or filtering or doing something to the elements of the stream, the results are then merged back together using a merge function that's passed as another parameter to the JavaTeeing collector. So the basic idea there is you can do several things to the same data, two things to the same data, two different types of things to the same data, and then merge the results. And you might ask, why the heck would you want to do that? And that's part of what we're going to be talking about here with an example. So what we're going to do now is we're going to talk about how to apply the JavaTeeing collector. And this is going to be in the context of a really neat program that is not unlike your program that you've been doing for your assignments. And it crawls pages containing images in a recursively defined folder structure. So that should sound very familiar. So if you have a folder structure like this that we see here on the right, it'll go crawling around there, and it'll count the number of images that appear in that folder structure. And the example we're about to look at also showcases the Java sequential streams framework and some interesting features therein. So with that, let's go ahead and switch over and take a look at the code. And we'll probably break this down into a couple of parts to keep it manageable. So here we are in my EX42 folder or program in my Java 8 live lessons GitHub repository. And you can see here a couple things. We have the source code over here on the right, and we'll go through that in a second. And then on the left, we have the file explorer. And here we've got something called resources. And I want to talk about that first, because that's really what the program will be acting upon. And so what we've got is a recursively structured folder that contains various images. So we have images of kittens, and we have images of Halloween costumes. We have images of various other things. There's a robot here. There's a logo for some software that I developed, and so on and so forth. Logo from a bunch of bees, and so on and so forth. So this directory structure is recursively defined. You can see there's a top-level structure, and inside there we have the couple of subfolders. So you can see we have some files at the top level, then we have other files that are nested inside of other folders. And interestingly enough, you can see we can go down several levels, so there's different levels that we can go here. Lots and lots of different stuff here. And this particular set of files resides on the local file system on my development machine. But I have a mirror image of this that's on my website. And the program we're about to look at can crawl through the recursively defined folder structure in my website or any website, as well as going through my file system. And you'll see that when we look at the code. It cleverly abstracts away from where the information is actually located. And so what it's going to do, as we're going to see when we run it, is it's going to go ahead and traverse through these links based on some parameters we can give it. And it's going to count the number of images that appear within those recursively defined structures. So here's what happens when we run the program. The way we set it up is you can tell it how deep to recurse. So we can say, stop after 2 levels of recursion, don't keep going. That's what we do here. So when we get to the 3rd level here, we stop counting because we've exceeded our max depth. And then it finds images at each level. So there were 7 images in the images 1 folder. There's 7 images in images 2 folder. And then there's another 7 at the top level. And so we end up counting them, and we end up with a total of 21 images that were found during the crawl. Now, the only main difference between this and your program is that your program also downloads and transforms the images, whereas this one is very simple and just counts them. But the basic ideas are very similar. So that's how the program behaves and the data that it works on.